Okay, I didn't realize the video cut off. I think this is where I just started the truth table, so I gotta explain this again. So the Friday's lesson is just an extra lesson. It's really would have been more for the math studies exam, people taking the math studies exam, but anybody who goes to college would have to take a computer science class, and this would definitely be in that computer science class. So truth tables, this would have been just a lesson, but there wouldn't be any homework with it. There are some basic operations. Some of these should look real familiar, and or the not. The one that's new probably is the implies one. And then I was just started talking about, instead of writing out a sentence like it is raining, we could call that a variable, call it A. So then instead of writing the sentence it is not raining, we could say that's not A. So this symbol is just like the prime symbol that we would put here. So it could be in front also. So I was in the process of making a truth table. This is a truth table, pretty basic one, or I should say maybe not basic, but a short one that probably would never see on a problem, but just knowing what the definition of not is. So the last thing I said before the tape came off, or the recording stopped, I should say, is if I make a statement, no matter what the statement is, one of two things is going to happen. It's either going to be a true statement or it's going to be a false statement. So then if I put a not in front of it, if the original statement was true, putting a not would make it a false statement. And then the opposite happens here. If the original statement was false, not would make that statement true. So this is the truth table for not. All right. All that means is flip all the letters. Okay. Now let's do a truth table for and. So A and B. So what we do is we write down our two statements. And I'll actually write down, just make up a sentence. Milwaukee is in Wisconsin and Green Bay is in Wisconsin. The first part is true. The second part of the sentence is true. So then the entire sentence is true. So if we remember from shading, for and to be a true statement, they both have to be true. All right, so the second sentence maybe is Milwaukee is in Wisconsin and Chicago is in Wisconsin. The first statement is true. The second statement is false. So now if I look at the entire sentence and it's an and statement, that's a false statement, because and means they both have to be true. The third scenario would be something like this. Los Angeles is in Wisconsin and Green Bay is in Wisconsin. The first part is false. The second part is true. Overall, the entire sentence is false, because again, both have to be true for it to be true. And then the last scenario would be where both parts are false. Los Angeles is in Wisconsin and Chicago is in Wisconsin. Both statements are false, which makes the entire sentence false. Now, we don't need to be writing all this out. We just need to understand the truth table. So again, for an and statement, they both have to be true in order to write true. All right, let's look at an or statement. Again, whenever you are doing two parts of a sentence, there are four scenarios. And this is something you would want to memorize. It's true, true, and you usually do it in this order. True, false, false, true, and false, false. Just like we did up here. I can use this same scenario, but now I'll just change all these to ors. All right, so let's just act out each of these scenarios and see what we get. Milwaukee is in Wisconsin or Green Bay is in Wisconsin. All right, that's a true statement. Because remember, or would mean at least one needs to be true. So the second sentence, Milwaukee is in Wisconsin or Chicago is in Wisconsin, only one part is true, but since it's an or statement, this statement is true. So or, as long as one part's true, we're good. Third statement, again, similar to the second one, Los Angeles in Wisconsin or Green Bay in Wisconsin, one part of it is true, so again, this entire statement is true. And the last statement, Los Angeles in Wisconsin or Chicago in Wisconsin, neither part is true, so that is still false. So again, we're not going to write out this anymore. We just need to understand how to do a truth table for an and or an or. And they both have to be true in order to write true, or one of them needs to be true, at least one. And if you remember from shading, this was 1/4 got shaded. This was 3/4 got shaded. All right, so those should look kind of familiar. Now the one that we really haven't seen before is the implies one. Implies is basically saying, are you telling the truth? It's an if-then statement. So let's just make something up here. If you get an A, mom buys whatever, car. So one of four things can happen here. Again, the four scenarios, like any other problem, we have true, 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 false, false, true, and false, false. So let's act out these four scenarios and see if mom's telling the truth here. All right, first statement. You get the A, mom buys you the car. Did she tell the truth? The answer is yes. Second statement. You get the A, but mom doesn't buy you the car. Did she tell the truth? The answer is no. So remember, she made this statement. If you get an A, I'll buy you a car. Let's skip the third one because that's kind of the hardest one. Let's do the fourth one. You didn't get the A, so she didn't buy you the car. So again, she told the truth. All right. Now the one that's confusing for a lot of people is this third one. You didn't get the A, but she went and bought you the car anyways. Did she tell the truth? The answer actually is yes. Because remember, all she said is what she was going to do if you got an A. She didn't make any comment on what would happen if you didn't get an A. So if you didn't get an A, there's no way she could lie. So that one is actually true. Now what I always tell students how to remember this truth table is the only time it's false is when the first statement is true and the second statement is false. That's the only scenario where you would write false. All right, so those are the operations. Let's do, we usually would have time to do one example. I'll just, make one up. A and B or not A, something like that. All right, so make a truth table. I made this one maybe a little harder than what you would see on an IB exam, but in college you would definitely see something like this. So you see two letters, so you immediately just write the two letters. If there was a third letter, there would be 8 scenarios. Basically, it would be 2 to the x power. So three variables would be 2 to the third, which is 8. If there were 4 variables, that's the highest I've ever seen. That would be 2 to the fourth, which would be 16 scenarios. But if you have 2 letters, 2 to the second, there's 4 scenarios. Again, it's true, 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 false, false, true, false, false. And a truth table is similar to a proof where you can't skip any steps and you have to make sure you write every step down. So like order of operations, whenever we see something that looks different, we make a column for it. So order of operations tells us to look in the parentheses first. We already got a column for B. The first thing we would make a column for that's different is this not A. And if you remember what not means, that means to flip the A column. So all of these trues becomes falses. These two falses become trues. So we took care of that. Sometimes people ask, should we put a not B? Well, there is no not B up here, so no, we don't want to do that. So this is done. Now I keep looking in the parentheses and it's like, oh, I can make a column for this. B or not A. Now if you remember what or means, at least one needs to be true. Or if I see a true in either column, I will write true. Now I see 3 columns. Which 2 columns do I look at? Well, I look at the B column, and I usually like to make a little number here. And then I look at the not A column. So these are the 2 columns I'm looking at. If I see a T in either column, I'm writing true. Okay, well there's a T. Nope. Yep. And yep. So now this is done. And you keep going until you get to the final thing, just like a proof. You keep going until you get to the proof statement. Okay, well now let's put it all together. A and B or not A. So now I'm going to cross these numbers out. The 2 columns I'm going to look at is the A column, which is over here, and the B or not A column, which is right here. Since it's an and statement, they both have to be true in order to write true. So when I look at these 2 columns, they both need a T in it for me to write T. All right, so I look at it. Okay, that one both had T's. Nope. Nope, I don't even have to look at the other one if that's a false. Same thing here. All right, so there's the answer to this problem. All right, so that covers this week, or actually it's next week, so I'm just a little ahead of the game here. So have a good week coming up.